Hey, this is Charlie Thompson, and I wanted to go over the Atmospheric Stability Lab, Lab 7, and do two example problems exactly as I would do them if I was a student. So here's the first problem, atmospheric stability activity number 1. We can take this twice. I'm going to read the instructions. I'm going to read all of the instructions before I start the exam because that's probably telling me things I need to know. So I can take it twice. That's good to know up front. Oh, look, I would very strongly suggest that you go through the practice problems before you start this lab. I think this is one of the more difficult labs because of the number of moving parts: specific humidity, relative humidity, maximum specific humidity, the dry rate, the moist adiabatic rate, the environmental lapse rate, temperature, dew point, and lifting condensation level. So you need to understand what each of those parts are and how they all fit together. So because of that, I've made up a sheet of practice problems with an answer sheet that you can go through and do those. And then I give you some instructions. If I was doing these longer questions, I'd copy down everything to a sheet of scratch paper, work it out on the scratch paper, and then plug those answers into the answer sheet. Let's take the quiz. And again, more instructions. These are the same instructions. You can take it twice, do the practice problems, copy everything. And then there's more instructions. I'm going to read all of these instructions. If the instructor wrote it, it's probably important. Hello, the way you enter your answers is part of your grade. Your answers will be marked wrong if they're not formatted correctly. If you're supposed to enter the lifting condensation level rounded to 1 decimal place and the correct answer is 2.0 and you enter 2, that will be marked wrong. For this quiz, please round as follows. Relative humidity to a whole number. So if you find 33.3%, the answer that you're going to enter is just 33. Dew point, please round to a whole number. So if the dew point that you find is 27.321 Celsius, just enter 27, round it to a whole number. Specific humidity, round to 1 decimal place. So if we find the answer is 6.666 grams, enter 6.7, that's rounded to 1 decimal place. Parcel and atmospheric temperatures, please round to 1 decimal place. So if we find the answer is negative 27.567 Celsius, the answer we're going to enter is negative 27.6, rounded to 1 decimal place. For altitudes, please give the value in kilometers and round to 1 decimal place. So the lifting condensation level is an altitude, so we're going to enter rounded to 1 decimal place. If we find 1.77 kilometers is the actual lifting condensation level, we're just going to enter 1.8. If you found 0.4, you need to enter the leading zero, like 0.4. We also need the online table. That's right here, the maximum specific humidity table. And then again, if I was doing these longer questions, I'd copy everything down to a sheet of scratch paper, work everything out, and then plug them in. So I'm just going to copy the whole thing, copy, and I'm going to paste it. That's looking good. I'm going to give myself a little space here. And let's get to work. So what do we know? This question is based on actual conditions during the Asian monsoon when orographic lifting produces some of the highest rainfall rates in the world. Take a parcel of air from the ocean up to the top of a mountain at 2,000 meters. Actually, that should be 2.0 kilometers. So we're going from sea level to 2 kilometers. The parcel has a temperature of 35 degrees Celsius and has 90% relative humidity. So the parcel's initial specific humidity, and I'm going to look that up over here. So at 35 degrees, the maximum is 36.4 is the max, times 0.9 equals, so we've got 36.4, 0.9 times, I get 32.76, which is going to round to 32.76 equals, oh, and if I was smart, I would have copied that. Copy. Now let's put that down here at the bottom so that I can refer to it. So that's a specific humidity, so enter 1 decimal place, so that's 32.7. I'm not going to enter grams, but because I want to remember what the units are for that answer, I'm just going to put grams as a reminder to me. So now we know what the initial specific humidity is, 32.7 grams. And now we want to know what the dew point temperature is. So we go over here and find, oh, that's nice, 32.7 grams. Slide to the left. The dew point temperature is 33 Celsius. So the next question, what is the parcel's lifting condensation level? And LCL equals temp minus temp dew point. So we know the current temperature. The current temperature is 35. The dew point, the temperature is 35. The dew point temperature is 33. So temperature divided by dew point temperature divided by 10 equals kilometers of lifting. So 35 minus 33. 35 was the temperature at the surface of the ocean. 33 is the dew point temperature divided by 10. So 35 to 0.2 kilometers. So 0.2 kilometers. Okay, so that tells us the lifting condensation level. So as the parcel rises to 0.2 kilometers, it'll cool down to 33 degrees. And now we want to know what's the parcel's temperature at 2,000 meters. So I'm going to put parcel So we know the parcel's temperature at 0.2 kilometers is 33 Celsius. And from 0.2 to 2 kilometers is 1.8 kilometers. We know that the parcel will cool the MAR of 6 Celsius cooling per kilometer. So we've got 1.8 kilometers times 6 degrees per kilometers equals, so let's go over here. We've got 1.8 kilometers. We're cooling at 6 degrees per kilometer. So that's 10.8 C cooler. So our temperature was 2 Celsius, right? I'm sorry, 33 Celsius. Dew point temperature was 33, so it was 33 degrees Celsius at the surface. It cooled to 33 degrees at 0.2 kilometers. So it's 33 degrees at 0.2 kilometers, and now it's going to go from 0.2 up to 2, and it's going to cool by 10.8 degrees. So 10.8 degrees cooler than 33. It's going to be 22.2. 22.2 Celsius. I'm just going to check that again. So we had 33 degrees, enter 10.8 minus 22.2. So we know the parcel's temperature at the top of the mountain is 22.2 degrees. So for a dew point temperature, we're going to round that to 22 and look it up on the chart. And the parcel's specific humidity is going to be the max. It's 22 degrees. It was 35 with a dew point of 33. So as it cools, all this water, it's going to be losing water until it cools down to 22 degrees when it can have 16.8 grams. Again, you're not supposed to enter grams in the answer blank, but there you go. And then how many grams of water vapor condensed? What did we start with? 32.7 grams minus 16.8 grams equals, get the calculator back. So we've got 32.7, enter, minus 16 is 15.9 grams. Okay, so now we've got all the answers figured out. And as I was going along, let's see, we've got how many grams of water vapor. If it's grams of water vapor, that's rounded to 1 decimal place. Parcel specific humidity, again, 1 decimal. the parcel's temperature, parcel temperature 1 decimal place, the parcel temperature 1 decimal place, elevations 1 decimal place, dew point temperature is a whole number. So the dew point temperature of the parcel, 33 Celsius, the initial specific humidity to 1. So let's move that over here and we'll plug in those answers. So the parcel's initial specific humidity is 32.7 grams. The dew point temperature is 33 degrees Celsius. The lifting condensation level is 0.2 kilometers. The parcel's temperature at 2,000 meters is 22.2 Celsius. The parcel's specific humidity is 16.8 grams. And how many grams of water vapor condensed? 15.9 grams. So if I was doing this for real, I would go through specific humidity, 1 decimal place, dew point temperature, whole number, lifting condensation level, 1 decimal place, specific humidity, that's 1 decimal place, and then how many grams of water vapor, that's a specific humidity number, so it's 1 decimal place. Submit quiz. The suspense is killing me. And it looks like I got them all right. Okay, that was cool. So let's do another problem. And this should be good because just like activity 1, I'm going to be doing this live with you. All right, let's take a look at a second example. And the first thing I'm going to do with this Lab 7 atmospheric stability activity is to read all of the instructions. They're probably exactly the same as the instructions that I just read, but who knows? Hey, I can take this twice. That's good to know. I strongly suggest that you go through the practice problems. This is one of the more difficult labs because of the number of moving parts: specific humidity, relative humidity, max specific humidity, the dry adiabatic rate, the moist adiabatic rate, the environmental lapse rate, the dew point temperature, and the lifting condensation level. You need to know what those are and how to make them fit together to solve the problems. I've made up a sheet of practice problems with an answer sheet. I'd keep doing them until they're boring. That is a good thing to do. If I was doing these longer questions, I'd copy everything down to a sheet of scratch paper, work everything out on the scratch paper, and then enter the answers. So let's take the quiz. And it's the same instructions from the first page. And now we've got different instructions. Hello, the way, and let me make this a little wider. Hello, the way you enter your answers is part of your grade. Your answers will be marked wrong if they're not formatted correctly. If you're supposed to enter the LCL rounded to 1 decimal place and the correct answer is 2.0 and you enter 2, that'll be marked wrong. For this quiz, please round as follows: relative humidity to a whole number. So if you calculate 33.3, you just enter 33, rounded to a whole number. Dew point, rounded to a whole number. In fact, it just occurred to me, relative humidity and dew point, whole number, everything else 1 decimal place. Oh, that just made everything super simple. Relative humidity and dew point to a whole number, specific humidity, parcel temperature, atmospheric temperature to 1 decimal place, for altitudes 1 decimal place. Use either the online table, a moose is watching us, or the PDF version. If I was doing these longer questions, I'd copy everything down. So here we go. In this exercise, I'm just going to copy everything, copy, and paste it here, paste. So in this exercise, we'll take a parcel of air up to the summit of a big mountain at 5 kilometers and then drop it down into a valley at negative 0.2 kilometers, 200 meters below sea level. So what are we given? A parcel of air at sea level. It's 15 Celsius with a specific humidity of 5.4 grams, a ground temperature of 15 Celsius, and an ELR of 9 Celsius. So if the parcel is lifted to 5 kilometers, so we know already what we're doing. We're going to be lifting and cooling the parcel. We're also going to be figuring out the rate of cooling of the temperature and what the temperature of the parcel is. So let's start. What is the dew point temperature of the parcel. So we know the specific humidity, 5.4 grams. If we know the specific humidity, we look it up on the chart. 5.4 grams, the dew point temperature is 5.0 degrees Celsius. So it's the temperature of an air parcel round to 1 decimal place. What's the lifting condensation level? So the lifting condensation level, to find out how far we have to lift to find it, is temp minus dew point temp divided by 10, because the dry rate is 10 degrees of cooling, and that'll tell us how many kilometers of lifting. The dry adiabatic rate is 10 degrees of cooling. So the temperature is 15 minus 5 divided by 10. So 15 minus 5 is 10. 10 divided by 10 is 1 kilometer of lifting to LCL. So the lifting condensation level is 1.0. Let's see, is that correct? For an altitude, please give the value in kilometers round to 1 decimal place. So 1.0, yes. And we already know, we don't know. I was going to say, we know what the temperature of the parcel is at 1 kilometer. So the temperature of our parcel is 5 Celsius at 1 kilometer, right? So it's going to cool, it's going to rise another 4 kilometers, cooling by 6 C per kilometer. So 4 times 6 equals 24.0 big C. So it was 5 minus 24. I'm going to break out the calculator because I don't trust myself. 5, enter, minus 24, I get negative 19. So the temperature of the atmosphere is negative 19, but it's an atmospheric temperature, so it's got to be 19.0. I know it's 19 even, but if we're talking about the parcel or atmospheric temperature, you round to 1 decimal place. So stable or unstable, we just need to pretend that we're Paris Hilton and ask who's hotter. Let's see, the parcel. Oh, we forgot the specific humidity. I'll have to go back and do that. So the temperature of the parcel is negative 19. I'm sorry, the temperature of the atmosphere is negative 19. And the temperature of the parcel, I think I said I was going to do this, mistakes and all, but I'm just going to cancel this because I think I put that in the wrong... Oh, I just put that in the wrong spot. Never mind. Cut. So the temperature of the parcel is negative 19 degrees. Negative 19.0 Celsius. 5 minus 24 equals negative... I'm just going to start over. Okay, let's take a look at another example from Lab 7, atmospheric stability. This time we're going to be doing lifting, finding the stability of a parcel, and then watching that parcel sink. So the first thing I'm going to do is read the instructions. Howdy, you can take this twice. That's good to know. I would strongly suggest going through the practice problems before starting this lab. I think this is one of the more difficult labs because of the number of moving parts. Specific humidity, relative humidity, maximum specific humidity, dry adiabatic rate, moist adiabatic rate, environmental lapse rate, dew point temperature, lifting condensation level. You need to understand each of those and how they work together. I've made up a sheet of practice problems with an answer sheet. I'd keep doing those till they're boring. Finally, if I was doing these longer questions, I'd copy everything down to a sheet of scratch paper, work everything out on the scratch paper, and then copy the answers to the quiz. So let's take the quiz. These quiz instructions I just read, so I don't need to read those again. These are new though. Hello, the way you enter your answers is part of your grade. Your answers will be marked wrong if they're not formatted correctly. You're supposed to enter the LCL rounded to if you're supposed to enter the LCL rounded to 1 decimal place and the correct answer is 2.0 and you enter 2, that'll be marked wrong. So for this quiz, and I just figured out a way to make this way easier, relative humidity, dew point temperature, round those to a whole number. Everything else, specific humidity, round to 1 decimal place. Parcel and atmospheric temperatures, round to 1 decimal place. Altitudes, round to 1 decimal place. I need to use the online table or the PDF version, the chart of maximum specific humidity. That's cool. And again, the instructions or the hint, if I was doing these, I'd copy everything down to a piece of scratch paper, work it out on the scratch paper, and then enter the answers. So I'm just going to copy everything from question 1. Paste it onto a sheet of scratch paper. Let's see what we have. In this exercise, we'll take a parcel of air from the summit of a from sea level. We'll take a parcel of air up to the summit of a big mountain at 5 kilometers, then drop it down into a valley at 0.2 kilometers below sea level. What do we have? We have an air parcel at sea level, so we know how high it is. At 15 Celsius, we know its temperature. Specific humidity, we can figure out relative humidity and dew point temperature if we need to. Also lifting condensation level. We know what the temperature is on the ground. That's going to be the same as the parcel to start. And the ELR, the environmental lapse rate. So answer the following questions. If the parcel is lifted to 5 kilometers, so right now we're lifting, what's the dew point temperature? Okay. So we know the specific humidity is 5.4 grams of water vapor. So we look that up. Oh, there it is. 5.4 grams. We slide to the left and we find the dew point temperature. In this case, it's 5.0. Let's see, dew point temperature, round to a whole number. No, it's 5. Dew point temperature, round to a whole number. Dew point temperature, 5. Lifting condensation level. So to calculate the lifting condensation level, you take the temperature, the difference between the temperature and the dew point temperature, divide that by 10 to find out how many kilometers of lifting you're going to need to do. So what do we know? We know the temperature, 15. We know the dew point temperature, 5. So 15 minus 5 is 10. Divided by 10 equals 1 kilometer, in fact 1.0 kilometers of lifting. So the lifting condensation level is actually going to be 1.0 kilometers. Okay, what is the temperature of the parcel at 5.0 kilometers? All right, so the temperature of the parcel was 5 Celsius at 1 kilometer. So parcel is 5 C at 1 kilometer. So 4 kilometers up times 6 degrees of cooling, because it's cooling at the moist rate, right? It cooled to dew point temperature of 5 Celsius at 1 kilometer, so now it's going to go up another 4 kilometers. Cool at 6 equals 24 C, 24.0 C. So the parcel was 5, so 5 minus 24 equals negative 19, since that's the temperature of the parcel. In fact, that would have been there. That would have been there. So the temperature of the parcel is negative 19.0 Celsius. And now we know the temperature of the parcel, negative 19. If we know the temperature, we can find the specific humidity of the parcel. So at 0.9 grams, you slide to the left. The dew point temperature, oh, I'm sorry. We know the temperature, negative 19, we slide to the right, 0.9 grams. 0.9 grams. If it's specific humidity, round to 1 decimal place. That's good. What's the temperature of the atmosphere? So the atmosphere, we know what the temperature at the surface was, 15 Celsius, and we know what the ELR is. So it's going to cool by 9 Celsius as it goes up for 5 kilometers equals 45 C So it was, so 15 minus 45 equals negative 30.0. So the temperature of the atmosphere is negative 30.0 Celsius. Is the parcel stable or unstable? You just ask who's hotter, the parcel or the atmosphere. The atmosphere is negative 30. The parcel is negative 19. The parcel is hotter. Negative 19 is hotter than negative 30. So I'm just going to put unstable. So we're done lifting. Now it's all downhill. If the parcel sinks from 5 kilometers to negative 2, it's going to heat up at the dry rate. So the difference between 5 and negative 0.2 is 5.2 kilometers. Cooling by 10 C per kilometer equals 52.0 C warmer. So 52.0 plus the temperature of the parcel was negative 19. I'm going to call it my trusty calculator. So we've got negative 19.0. No, that's not even right. 19.0 negative, and then we're going to warm by 52 degrees. 52 plus, we get 33.0 for the parcel's temperature on the ground. 33.0. The parcel's specific humidity, it doesn't change. The specific humidity, remember, it's how much water vapor you have. The parcel, as it gets warmer, can have more water vapor, but it doesn't mean that you get it. For example, if you're a parcel of air and you're warming up in Reno or Las Vegas or Death Valley, it doesn't matter how hot you get, there's no more water for you to absorb. It just doesn't matter. So as the parcel sinks and heats, the specific humidity doesn't change. So whatever the specific humidity was at the top of the mountain, 0.9 grams, that's what the specific humidity is at the surface. So the relative humidity, equals specific humidity, what you have divided by max. Specific humidity times 100 equals 0.9 divided by, and the parcel is 33, so the parcel could have 32.7. The parcel, I don't even know what happened there. 32.7 equals, so we have 0.9 divided by 32.7 times 100, I get 2.752, and when we round that, I get 3%. So rounding 2.752 up to a whole number, I get 3%. So now let's enter these and make sure that everything is formatted correctly. So relative and dew point are whole numbers. So the dew point is 5, whole number. Lifting condensation level is 1.0. The temperature of the parcel is negative 19.0. That's a parcel temperature, so that's rounded to 1. Specific humidity of the parcel at 5 kilometers, I get 0.9 grams per kilogram. That's specific humidity grams, so that's rounded to 1 decimal place. What's the temperature of the atmosphere? I get negative 30.0. Is the parcel stable or unstable? Well, we already answered that, unstable. And now we're doing the sinking. What's the parcel's temperature at, what is the parcel's temperature? 33.0. The parcel's specific humidity is unchanged at 0.9, and the relative humidity is 3%. So what am I looking at? Relative humidity, that's a whole number. Dew point, that's a whole number. Everything else rounded to 1 decimal place. Submit quiz. The suspense is still 9 out of 9. So that's all good. I'll put these in the Lab 7 module. I will assign them no points, so you can go through and do them for the experience of doing them and knowing that you know how to do it correctly. So there you go. I wish you, again, I wish you good luck on Lab 7.